Hi everyone. Now let's look at problem 139. Word break. Given a string S and a dictionary of strings, word take, return true. If S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in this segmentation. Input. So given, let me read the problem. Okay, let's look at the example. Example 1, we have input S, LeetCode, word take is lead and code. So I think the question statement is a bit misleading. It says S is a string and word take is a dictionary of strings. Alright, I didn't get it. So the meaning of dictionary here is just a list. It's not a Python dictionary in some sense. That is what I thought here. Alright, so example 1, we have LeetCode. And the word take is lead and code. So this one can be separated into lead. So I'm going to put left and right pointer here. So left at L and then right at T, and then another left at code, and then another right at E. Okay, so lead code can be separated into lead and code. Example 2, we have apple, pineapple. Word take is apple and pen. So this one can be separated apple, pen, apple. So output is true because you can segment the word into apple, pen, apple. Note that you are not allowed to reuse a dictionary word, or you are allowed to reuse it. Okay. Question 3, cats and CATS and OG. And the word take is cats, dog, sand, and cat. Return false because you cannot segment this string. We could actually segment into cats and, but the OG cannot be segmented further. Or we could do like a cat and then send, but again the OG cannot be segmented. Alright, so I think got the problem now. Just give me 1 second. think I understand the problem now. I just would like to I have a few questions that I would like to clarify. Clarify. One, what is the length of S and the length of... Okay, let's do it one by one. So length of S, the given length of S is between 1 to 300. And then how about the word date? So length of word date is between 1 to 1000. How about the length of word date of I? So it's given by between 1 to 20. Alright. So I think I got the necessary information for this question. I would like to start exploring the possible approaches for this question. I think while going through the example above, um, I think we could. So one thing that come to my mind is that we could use a try in this problem. Because if we use a try, then it's a bit easier to get all the string that start with a character, and then we just move along the tree, the try, to get the characters that follows. So I think we could do that. For example, we would have LeetCode. The first example we have LeetCode, so we could just see that the first character is an L, so we follow along the root and then go to the child which has an L, and then followed by E, so on and so forth. Till one point, if we have reached an end, then we just restart it. Or we could move along to the rest of the string towards the child. So let me try to... I think this problem is a bit complex, so let me try to do that for the first question. And then try to simulate what you're gonna do here. So LeetCode. What we're gonna do is we use LeetCode. So we will move along from L towards T. And then we do it again for code. So C to E. So that's how we return true. Second one is basically the same. So let me just move on to question 3. We have cats and OG. So if we do CAT, or we could also do CATS. So if I do CAT, it means that I will have to start with S the next for the next word. So let's do that. So CAT, and then we have SAND, and then OG we will have nothing. So nothing for OG. So we return false. And then another possible thing is we use CATS, and then we take the end. So from A to D. But again, the OG cannot be for there's no word that start with OG. And we don't have OG in the word D. So here, so I see a recurring checking here. When we check CAT, we know that CAT is in the tree. But when we check whether CATS is in the tribe, we basically don't need to check whether uh, we could just skip from CAT and then we check whether there is a CATS because we know that CAT exists. But how do we do that? That is the question. How about we use a recursive? So I'm thinking if we could do it recursively, then what we would have is we go to the string and then we end at T and then we split up. Is that possible? How about we just look at the subproblem here? So CATSAND. If you want to know whether there is a way to break it down into two words, then so what I will do is I will check CAT and then I branch out restart at S, and then look for SEND. Or I could also continue in the other branch. That will be CATS. And then AND. I will check for AND. And then we will check for OG. So basically, when I check to OG, I don't need to redo it. So um, I'm trying to do a memorization of my checking, so that I don't need to go through it twice. Right. So how about I use an array to check whether there is a solution? Oh no, actually, if I have found a solution, then I don't need to store it, so I just return true. Um, okay, but I guess we still need to check. If we start with a new character, then we basically restart the track. So what I would do is I will check CAT and then I branch out to two possibility. If I reach a word, then I'm gonna restart it. But how many combination is possible here? If I have okay, I think of something here. So let me write down the example for. For example, when we have let's say A and then B. Our dictionary we have A, and that's all. So in this case, we could do A, and we could sorry. What we could do is that we take A. So X. I'm gonna write down X as a replacement for left back in the same character. So X minus. Or we could do A, but then at this point, we don't need to check whether there is AB, whether AB could be breakdown into words, right? So we could use a basically an array to store whether if it is possible if we stop at a certain character and then do we need to check further? If it is not, then well, there is no point. Okay, I think we can do that. But then in terms of the implementation detail, let me think for a second here. So if we just use an array to store that, hmm, so if we use an array, then we basically can uh, check. So we just keep a check if there is no possible solution there. Okay, let me write down a quick example, which is similar to example 4. So if we have A, and dictionary is A and A, basically we could just take X. So we break down into 3A, and then we return true. You don't need to check whether there is, you don't need to explore the further using the AA and then A, because we have found the solution. So I'm thinking whether there is a good way for doing this. So there are two things that we need to do. First one is whether we have found a solution. Hmm. Okay, let me go to the example 5 here. So I'm thinking that if we go through the AAA, then in the end, when we reach the last A, then we basically set it to true. Let me write in the F as a solution. So F would be true. Then that's how we got the solution. So that the next time we check AA, we don't need to do that anymore. Sorry, actually. How about I use another array S? to check whether there is a solution for the rest of it. If we um, start with that character, I mean, we use that particular index as a starting point of a word. So that will be F, right? Yeah, that will be F. Okay, let's look at example 1 back. Example 1, we have lead code. So we start with LEET and CODE. So the C here would be true, and the L here would be true. Okay, now example 2, you have apple, pen, apple. So the last A we will find that is true, and pen is therefore also true. And then the first A will be true as well. Example 3, we have cats and OG. Now we find that O, if we start with O, there is no solution. So it means that when we first check, let's just say we start with cats, CAT without S. So send is also false. And then we further explore another option, which is cats, CATS. And then we found that A is also false. And because when we do AND, we see that O is false, so A is also false, and we are left with no other choice. We have to set C as false. Alright, I think this sounds reasonable to me. Does it make sense to you? I'm pretty good about this, and I would like to start programming unless there is further optimization that you would like me to explore. Okay, I guess here I would start with creating a node for the tribe. I'm gonna define node. So this should be class node. Then I would have init. I'm gonna store two things. First the value, and then where is it, and the current, if it is a word and. So I'm gonna call it word. Hmm. Actually, let me just Google a bit on how we're gonna create a trinode. So let me just look at some solution from LeetCode. So we have children and word. Okay, I think I just follow the implementation that is provided. Oh, it's actually a try. So the class itself is a try, and the init would be, it would have sorry, let me just copy the implementation so we don't have to worry about the correctness of our try implementation. So try will have children, which is a dictionary. Then we start if it is a word, which is initialized to false. And then there is a function to add word. So word um, current start itself. Also, it's not a try, but it's a try. Let me just call it node then to simplify our code. Okay, so current is self here. For C in word, I'm gonna do if C not in cur dot children. I'm gonna do cur dot children of C equals node, and then cur will move to the child. Instead of children, I'm gonna call it child to simplify the whole code. Child of C, and then cur dot is what equals true. Okay, so now we can start with our solution. I am actually gonna use a recursive solution. So let me define f. So what we need here is the index, I think. The index and the node. So what we do here, we the I and the index I and the node. So basically, what we're gonna do is we check whether we have explored that option. So let's do it. Uh, Actually, let me just build the node first, the type. So we have given word list, if I'm correct. Yep. Oh, sorry, word pick. So I'm gonna create a variable called try, which is initialized to the node, and then I'm gonna loop through the word in word pick or word in word pick. I'm gonna call try dot add the word. Okay. And now I'm gonna call a found. Found is initialized to false and has a size which is the same as length of s. Okay. Now I will create the solution, which is the main part here in our question. I'm just gonna accept I and the node. Okay, so what we do here is that we check whether we have found we have found it before. Hmm. I think instead of a boolean, so how about we just separate it into two parts. Okay, but I will create another variable called break, which is also initialized to false. And we'll have length of s. And then the found, I'm gonna give it another name. Um, so let me just keep the found and the break. So found here is I'm gonna use it to store whether there is whether I have explored a possibility of breaking down the rest of the word if I start with that index I. So found here means that whether I have checked it or not, and then break would be to indicate whether there is a solution or not. Okay. So I think I'm good to move forward now. So first of all, when we first enter the function, we're gonna check whether um, we have found it. I mean, we start with it. So how do we know we're starting with it? Okay, so the function has to set another parameter. Which I am gonna call start post. So here I'm gonna check um, if found of I, then basically I will return the break of I. Okay, and then what we're gonna do next is we found I. If we haven't found it, then we basically explore it. So I think I need to check if we start, if it is a starting point, and then we found it before, then we basically return the break of I, meaning that if there is a way to break the rest of the string S. Otherwise, we just continue. So if S of I is in node.child, then we basically recursively move to the next index. And then this would be node dot child of S of I. So we first of all need to check if it is an end of a word or not. Mm. Actually, this is not what I want to check. Should be checking if si class 1 if si plus 1 not in not dot child, then we just directly return false because there is no need to explore it. Turn false. Otherwise, we need to explore. Enter the next character. Hmm. Fine. I'm a bit confused here. So let me give him a moment to think through this again. Um, so for the first example, I'm gonna start with L and we'll indicate it as start. And then we'll check if E is in the chart. If E is in the chart, then I just continue. However, at T, I see the C. C is not. Okay, so if T is a word, then basically I start a new thing. So I need to indicate start as true. Okay, so here I will need to check whether node dot child s of I plus 1 is what? So if it is eastward, then I will move forward with the index and then call the node.child of s of I plus 1, and then start with true. And I also need to explore the other possibility that it is not a child. Okay, so if I just don't want to end it there, I could do this. And then here, I miss something. If it is a start, then I need to set the bound to true. Bound I equals true. And then break I equals false. Okay. Now in the second if not child is a word, then I explore it. Actually, this one I don't need to uh, move it there, so I'm gonna call a let's see. Okay, I'm gonna call a result, which is initialized to false. So inside the if, I'm gonna check result or equals to. Okay, so I check whether there is a possibility that we start with that. Or we could also check result or equal f of I plus 1 and then node or child of s of I plus 1, we just basically continue with that. Actually, let me rewrite this. I think I got a better idea. Um, so instead of doing this, we do result equals false. Then we check if s of I plus 1 is in node.child. Then we can check further. So if not, I'm gonna just use a n.c of s of I plus 1 dot is word. Then I'm gonna do result or equal f of I plus 1, then not dot chart of s of I plus 1, comma true. Then also result not r with a plus 1 and c as I plus 1. Okay. Actually, in the beginning, you should check whether I is the length of s. Then we return true. Okay. After we get this check, we see whether it is a starting point. If it is, then we set bound of I to be true, and then the break of I equals result. Then we return the result. Okay, now let me go through the code again to make sure I don't miss anything. We have a try there. Word date, we added all, and then we call an f. So f of this would be the 0. Actually, what we need to check is not s of I plus 1, which is wrong. What we need to do is the s instead. S of I, sorry, s of I. So we just, in the end, we call the f of 0, comma, try, comma, true. Okay. So when we first enter the function, we check whether it is a start. If it is a start, then we check whether it is a bound. If we have found it, then we will just return the break so that we don't recompute everything. Otherwise, we have this result variable which is initialized to false, and then we check if the s of I is in the tribe. If it is, then we can check further. If not, the tribe of s of I is a word, then we basically can start with a new thing here. So result of f of I plus 1, and then we continue down the chart. Now remember, if it is a word, then we set the start to be true. And here there is a minor optimization that we can do. I just think of it. If not result, oh actually I think Python can handle that, so we don't need this. Yeah. So we also explore the possibility that if we don't end it there, okay, which is the second result there. And then in the end, if it is a start, then we store the value for future reference, and then return the result. Okay. Now let me test the code with our input to make sure it works as expected. First example, we have LeetCode, LeetCode. So when we first enter, the start is true, but we haven't found it. So at the top, let me just create a found and then break. Now if we start at L and then S of I is in the node. So L is in the dictionary. So we can do that. But it is not a word. So we just move forward E and then E is there. Actually there's a mistake here. So if we start with a new thing, then we basically need to pass in the try. So when we work on the lead, Leet, Leet, and then we see that T is a child. So we start with the C again, and we pass in the try so that we could start from the beginning of the try again. In the end, we see that when we reach E, then next time we restart everything, but we found that we have reached the end of the string S. So we return true, and then there will be the true. We propagate back to the C. So C would be true, the font would be true, and then the break would be true. Which is also the case when it propagates back to the L. Okay, so that works. Now let's look at example 3. We have CATSANDOG. So again, the font, the break, and the start. We start CAT. Now T, we start again with the SAND, and then OG. We have found that if we try to start with O, the break would be false. Therefore, no, there is another possibility. When we go through SAND and we look for SANDO, O is not there, so it's also false. So basically, if we start with S, it will give us a wrong result. So font is true, brick is false. So how about when we start with A? So we take CATS and then we start with A, and then we found that we end up with O again because we have AND but we don't have ANDO. So this would be true and then false. The end result, you would see that the font will be true, brick will be false. Okay, so I think this should work. Let me input my solution to LeetCode to make sure it works as expected. So class node define init cell self.chart equals a dictionary self.isWord equals false. Actually, let's just use a default tick. I think it could help. Collections import default tick. Here I'm gonna call can I do a default tick of itself? Python, let me look at it. Class member default of itself. I think it complicates stuff, so let's not do that. So define add self work cur equals self or C in word. I'm gonna do if C not in self.chart self.chart C equals a node. So I think we can use a default tick then. Collections import default tick. Open the self.chart current equals self.chart of C, then cur.isWord equals true. Now for the solution itself, I'm gonna call it try equals node for word in word tick try dot the word will create a form. Just initialize to false. This will be the length of size of s. And I do the same for break. Actually, I cannot call it break. Um, so let's call it solution. Or how about let me just call it word break. Okay. Now we define another function I, then call it node, and then start with false. Okay, let me just be specific. So let's not make it the default argument. So if start and found of I, actually I don't think I need. Do I need the word right here? And I think for one, because I might not need that, because Python or the or in Python will have a short circuit. If I have found one, then it might not do the rest of it. Okay, before I forget, this will start with another if I equals length of s return true. Okay, let's keep it. I think I need it. So here I will return the word break of I. Then here the result. initialize to false. Then if s of I, actually let me just call c equal s of I. And then if c in not that child, then if not the child of c dot is word, then result are equal f I plus 1, then this would be the try, and then the start will be true. And otherwise, we're gonna f of I, and this would be not the child of c start would be false. Okay. After this, you will check if it is a start, because if so, we need to memorize it. Memorize method to the memorization step. True, and then with break of I equals result. Then in the end we return the result. So here our solution would be return f of 0 try, and then start is true. Let me try to run this. Hopefully there's no error, but there is. Boolean is not callable. Okay, yeah, makes sense. We got false. So let's print out the font in the word look. Start is true, and then font line is false. So we need to explore it. Result is false. How about I print the try? Print not the child. Child dot keys then. LeetCode. How is it possible? So my try is wrong. try the add word. Okay, let's do some printing here. Okay, this is definitely not right. Um, print self.choice. Okay, current is not self.choice, it should be current. Yeah. Let me try to run it again. Correct. So let's try to submit it. Hopefully, no. AAA. Okay, this is not right. Let's use the test and then try to run it. False, 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 false. So, AAA, true. Okay, so I think I got it. So there's a problem here. If I is lang, but it is not a verb. So I'm gonna do this. Okay, if I is long, then it has to be start. Otherwise, we should not end there. Okay. So let me move it down. If start. Sorry. If start. If it is start, then okay, let's do it this way. If start, then we check if we have found it, then return the word grid. If we have reached the end, then else then we return true. Let's try to run this. Okay, let's move this now. It has to be the first thing that we check. Yeah. Typo again. String index out of range. Okay, so we cannot combine this. Sorry about that. Somehow that's what I'm thinking. If n is not blank, then we return whether it is a start or not. Yep. Okay. Hopefully this time we got it right. Yes. Memory wise, it's taking a bit too much. Let me try to run it again. Should be okay. We are not doing so well in terms of memory. I think that's okay. Let's look at some implementation out there. Oh, this is extremely short. Change if I is larger than the length of the current loop, then dp of I equals dp of I minus length of void. So this is doing a lot of slicing then. I doubt that it will be efficient, much more efficient than what I did. Let's look at another one. But I still think that you need to use a try. Unless Python can better optimize on this one. Yeah. No one is using a try here. But anyway, I think in terms of memory, we are not so bad. Hold on. Yeah. Let me sort it by time instead. I mean, in terms of logic, I think so far what I see is roughly the same as what I did, except that they are not using a try. They're just direct comparison. I think that works too. Then I guess I will stop here. So thank you everyone.